Good afternoon. I'm going to start off with an introduction into iGii. iGii is an R&D and manufacturing company based in Stirling in Scotland. We currently have 2 sites that we operate on, one in the center of Stirling and a dedicated high-volume manufacturing site based in the north of Stirling in the Stirling Innovation Park. We have a growing portfolio of intellectual property, and we are a team of multidisciplinary professionals with a headcount of 53, and currently have a few live open roles as of this week, so please do speak to us if you're interested. We have multiple long-term partnerships with diagnostics companies, and we are open to explore more opportunities to partnering. So again, please do speak to us if you're interested. So, going into the state of the art in the field of sensing and diagnostics, there is pressure to produce materials that are giving faster, more effective, and more accurate measurements. From a technical perspective, sensitivity and specificity are key to enable clinically relevant measurements that enable early diagnosis. And this is particularly important in situations where early diagnosis affects prognosis. Integration and miniaturization into already existing systems is also an important factor to development of point-of-care and portable diagnostics. From an economic perspective, cost, accessibility, and scalability is essential to ensure uptake, as well as equal access on a global scale. And now, from a more forward-looking perspective, as a generation of proactive engineers and scientists, sustainability must be at the core of materials development. And with the rising geopolitical tensions and new policies such as new tariffs, supply chain security must be considered even in the early stages of R&D. If we have learned anything from recent years, it's that it is important to develop platforms that are easily adaptable to meet the demands of sensing new and emerging diseases such as COVID, because lives depend on it. Current solutions on the market largely depend on the use of metal-based substances such as gold, which is a mined substance. No need to mention how much impact that has on the environment. Also polymer-based options, which are easier to integrate into flexible and wearable devices. Carbon materials, which are exceptional in terms of electrical conductivity, as well as having a wide potential window for electrochemical sensing. More recently, nanomaterials, which are highly sensitive due to the high surface area. These generally tend to be formulated into inks and are deposited to fabricate sensors using techniques such as screen printing. Taking all of this into consideration, at iGii, we have developed a breakthrough solution, G. G is an engineered 3D carbon nanomaterial that is grown directly onto a substrate. So that means there is no need for additives or adhesives, such as is the case with carbon inks, which opens up a wide range of applications that carbon inks may not be able to meet. However, we do maintain the customizability as well as the scalability as similar to printed sensors. From a technical perspective, in terms of properties of G, chemically speaking, we know that G is a graphene-related material. These 2 spectra here are